Good morning, class. Today we will be tackling linear relationships. In other words, we will be learning how to write an equation using our non-linear formula, y equals mx plus b, using descriptions, tables, and graphs. All right, so let's go ahead and get started. All right, so as you know, our formula for a non-proportional relationship is y equals mx plus b. Remember, our m is our slope, and our b is going to be our y-intercept. And our y-intercept is just the point in which our line would cross our y-axis. All right, one thing that might be helpful if you want to take notes alongside with me, that way you can follow along. All right, so when we're looking at slope, there are a lot of things that can go into finding slope. And depending on the problem, you might want to use one over the other. So typically rise over run and our slope formula are used when we see graphs, because we can take one point, right, on our graph and we can rise and run, or we can pick those two ordered pairs and plug them in. The slope formula is also helpful if we are using tables, because again, we can take that x value and that y value and plug them in. But also for tables, we can use the change in y and change in x, and I'll show you what that looks like in our examples for today. All right, so for our first example, let's tackle some graphs. So we know that we're looking for our formula is y equals mx plus b. That's our equation. So we need to plug in, and we need to find our m, and we need to find our b. So I'm going to start by finding our b, or our y-intercept, by first looking at our y-axis, right, and seeing at what point we cross this graph. And by looking, I can see that that point is right here. Right, and this point on the graph would be 0, 2. And so I know my y-intercept, it's also above our origin of 0, so this is going to be a plus 2 because it's a positive 2. All right, if it had been down here, it would have been a negative 2, but luckily we have a positive 2, so I'm going to plug that in. Now for m, we can do one of two things. We can do rise over run, or we can do the slope formula. For this one, I'm going to go ahead and do rise over run, so that way y'all can see what that would look like. So for this one, I'm going to take my first point, and I'm going to rise, and I'm going to ask myself how much I went up. So I went from 2 to 3, so I went up by 1. So that's how much I rose. So rise over run. And then I'm going to hop here. And it's one hop, right? It's one loop. But if we look at our graph, right, this is 0, and we ended at 2. So because our graph is numbered by 2, this is something to be something to notice, is that we actually moved by 2, right? One hop, but on our graph, that's going to be 2 points. So we rose 1, ran 2. So I'm just going to plug that in. We rose 1, ran 2. So our slope would be 1/2. So to rewrite this, our equation would be y equals 1/2 x plus 2. All right, let's go ahead and check out another graph. All right, now for this graph, all right, if we were to look at our points, we have our y equals mx plus b. Our b would be this point right here, which would be at 0, 3, which would mean that our b is going to be plus 3. And then for our m, for this one, I'm going to go ahead and use the slope formula. Our formula is y2 minus y1 divided by x2 minus x1. All right, so I'm going to go ahead and find 2 points on the graph. We already found our y-intercept, and then I'm going to use this other point over here, which is going to be at 2, 0. And so these are going to be my 2 points. And like I said when we did this in class, it's important to label your pairs. So I'm going to go ahead and label this one x1, y1, and then this one's going to be x2, y2. Notice, they're labeled this way because this is my first ordered pair and this is my second ordered pair. 1s and 1s, 2s and 2s, and I'm going to go ahead and plug those in. So first we have our y2, which is 0, minus our y1, which is 3, divided by our x2, which is this one right here, 2, minus our x1, which is right here, which is 0, right? 0 minus 3 is negative 3. 2 minus 0 is 2. And we don't have to simplify, we can leave it just like that. So now I know that this is going to be my m. All right, so if I were to rewrite my equation, I would get y equals negative 3 over 2 plus 3. And we can always check our answer, right? Our y-intercept looks good, and we have a negative slope. And if we were to do rise over run, we would rise 3, run 2, and our slope and our formula checks out. Now that we've done graphs, let's go ahead and move over to descriptions. So for descriptions, it's important to know which piece belongs to what. So we have our formula, y equals mx plus b. Typically, when you have a b, this is going to be an additional charge, right? It's going to be something added on or subtracted, right? But it's by itself. It's solo. And then our m is typically triggered by a word like per, each, and every, because it's something that's being multiplied, right? Because we have to multiply it by our x or whatever that variable would be in our problem, all right? So knowing that, go ahead and jot that down if you need it. We're going to go ahead and take apart this first description. So it says a plumber charges $25 for a service call plus $50 per hour of service. So if we're looking at it, they charge $25, right? That's kind of just standing by itself. There's nothing tagged onto it. Then if we come down to our 50 right here, it's connected to this word per. And if we look at our keywords, per is one of those words. So I'm going to go ahead, and when I write my equation, I'm going to plug 50 in for my m. And then it charges $25. So that's just a flat fee that you're going to get regardless. And it's going to be added on top of your bill, right? So it's very important to read your equation to know whether you're going to be adding or subtracting your y-intercept, right? In the case of this plumber, right, you're going to get this charge and this charge added together. So you're going to get a total bill from your plumber. So our ending equation is going to look something like that. All right, let's try one more. So it says Dominic collected 100 pounds of aluminum cans to recycle. He plans to collect an additional 25 pounds each week. So again, we're going to start with our formula. And then we're going to start looking for our keywords. So he collected 100 pounds. And that's just kind of there. He went collecting some cans to recycle. Really good, Dominic. Then he had an additional $25 each week. So there's our keyword right there. Winner, winner, chicken dinner right here. Each week. So every week, week 1, he's going to have 25. Week 2, he's going to have an additional 25. So it'll be a total of 50. So notice how we're increasing each week. So that will be our M. And then which leaves our 100 to be our B. So if we were to rewrite this equation, we would get y equals 25x plus 100, because we're looking for the total amount of cans. So we're just going to be adding these two things together. So let's go ahead and move on to our last example, which is going to be tables. So for this one, I'm going to show y'all how to do change in y divided by change in x. All right, so for this one, first we're going to ask ourselves how our y is changing. So what I mean by that is we're going to ask ourselves, how do you get from 4 to 6? Well, you're going to add 2. How do you get from 6 to 8? Add 2. 8 to 10, add 2. 10 to 12, add 2. Now we're going to do the same thing for our x. Negative 2 to negative 1, we're going to add 1. Negative 1 to 0, we're going to add 1. 0 to 1, add 1. And you guessed it, from 1 to 2, we're going to add 1. So if we're going to plug this in for our m, right? Our change in y was 2, and our change in x was 1, which means our slope for this one is going to be 2. So if I have my equation, y equals mx plus b, we've just found our m, which is 2. Now, if we're going to find our b, b is our y-intercept, or in other words, b is going to be when x equals 0, right? Because that's when it's going to hit on our graph. It's going to hit our y-axis when x is 0. So we're going to come through, look at our x column, and then we see when x is 0. So when x is 0, y is 8, and so our b will be 8. And so if we were to write this all together, we would get y equals 2x plus 8. All right, so let's go ahead and do our last example. All right, so we have another table. Remember, we are still doing y equals mx plus b. However, for this one, I'm going to go ahead and use our slope formula. So again, that's y2 minus y1 divided by x2 minus x1. Now you could definitely just use our change in y, change in x. I just want to show you both ways, and then you can pick which one works best for you. So first, we're going to label our points. So when I come here, I'm going to have x1, y1, x2, y2. And again, you could pick any points. You could pick the first row, the last row. It doesn't matter. Either way, you should get the same answer. And then we're just going to plug them in. So for y2, we should get 11, right here, minus our y1, which is 3, divided by our x2, which is right here, 2, minus our x1, which is right here, and is 0. So then we're going to do 11 minus 3, which is 8, divided by 2 minus 0, which is 2. Then we have 8 divided by 2, which is 4. So our slope here is 4. So now that we found our slope, check, we need to find our b, which is our y-intercept. And for these tables that you're going to see for the lesson today, we're going to be able to find our y-intercept pretty easily by just looking on our graph for when x is 0. So when x is 0, our y equals 3, which means our b equals positive 3. So to write this all together, y equals 4x plus 3. All right, and that's all I have for you today. So go ahead and continue with the Nearpod. And then after the Nearpod, there's a short quizzes assignment for y'all. And y'all can compete against each other and see who can get the high score. All right, have a good day.